Greetings and welcome to another R video. In this video, I'm just going to quickly show how to do Factorial ANOVA in R. It's very simple. It's a straightforward extension of analysis of variance, but it's something that I'll be teaching in my class soon, and so I wanted to make a quick support video for it. So, in this video, we'll be using Janitor for its alternative table option, probably tidyverse for some stuff, and the effect size package, which will give us partial eta squared for the Factorial ANOVA we're going to do. The data set we're going to use is an experiment on, it's a third parties experiment where we gave people different versions of an article, and the article either contained a third-party candidate who is challenging an incumbent in the general election, or a same-party candidate that was challenging an incumbent in the primary. So this third, if we look at the this third variable, there are a bunch of people who read an article about a same-party candidate challenging an incumbent in the primary, and a bunch of other people read an article about a third-party candidate challenging an incumbent in the general election. And then the challenger, regardless of whether it was the primary election or a third-party election, the challenger was either challenging the candidate from fringe position, meaning that they were arguing that the incumbent was too moderate, too centrist, sold out to elites, and that the voters should prefer somebody who was further to the left or further to the right of the candidate, or the candidate was challenging them from the middle, saying that the incumbent was too extreme. And so half of the people read an article where the challenger was from further to the right or left of the candidate, and the other half read an article where the challenger was from the middle. And the outcome we're looking at here we're looking at likelihood of voting for the challenger. So higher scores means people are more likely to vote for the challenger. It was on a 1 to 7 scale, so you can see the minimum is 1, definitely not voting for. The maximum is 7, definitely would vote for. And the average is close to but underneath 4, implying that on balance the incumbent was favored over the challenger. So the question, I guess the three questions that we want to ask with this Factorial ANOVA are, was the third-party challenger more or less likely to get voting support compared to the same-party challenger in a primary? And so that would be the first question. The second question would be, is the fringe candidate more or less likely to get vote support compared to the moderate candidate? And then the third question would be, do these two things interact? In other words, if you're a third-party challenger, is it more beneficial to challenge from the fringe or to challenge from the middle? So we can do a simple Factorial ANOVA to check that out. We will say M1 equals AOV, and this is the structure of basic ANOVA. So M1 is just model 1 or whatever you want to name it. This name's arbitrary. And then equals AOV is the command for an ANOVA. Vote is our outcome variable. And then tilde, we're going to put both factors here. So we're going to say third and fringe. And we're doing this time sign to indicate that we also want the interaction of the two factors. And then we're going to say data equals TP, which is the name of my data set, and run that. Now if we get a summary of model 1, this will give us, let's get this a little bit further over. If we get a summary of model 1, this will show us the results for all three questions. So the first question is there a difference between the third-party candidate and the same-party candidate? And the answer is yes. You see those stars indicate a significant p-value. The E-06 means that we move this decimal 6 spaces to the left, and so it would be, move it past the 1, and then 0, 0, 0, 0, 0, and so that's a p-value less than 0.05 or less than 0.001. We have our f value for the factor here, and then the between subject's degree of freedom is only 1 because there's only 2 levels to it, third party and same party, and so k minus 1 equals 1. Same thing with fringe. The degrees of freedom is 1 because k minus 1, there's only fringe and center, so we get 1 degree of freedom. We get our f value, we get a significant p-value again, and then for the interaction third by fringe, you'll notice that the p-value is approaching conventional levels of statistical significance, but it's not statistically significant itself. The p-value is 0.09. So we would conclude that there is an effect of whether you're in the third party or the same party, a third party or the same party, and there is an effect of whether you're the fringe or the centrist challenger, but that these two effects don't interact, though we could say, well, it's approaching conventional levels of statistical significance. So that gives us our ANOVA table, and then the next thing that we want to do is get our effect sizes to determine if the effects are different in a meaningful way, and that's why we have loaded this effect size package, and if you haven't installed it, you'll also need to install it, right? Install.packages effect size. But assuming you've already installed and loaded it, then you just, we want eta squared for this. It'll actually give us partial eta squared, which is the same thing that SPSS gives you, though you can change that option, I suppose, if you want. And it gives us this effect size for the third party effect, which is 0.03. Which is, I believe, a moderate effect size for eta squared. And then for the fringe, it gives us a 0.07, which I think in eta squared is considered a reasonably good-sized effect. And then the interaction is 0.003, which, again, it makes sense that it's not a very large effect because it's not statistically significant at conventional levels. And then, of course, the last thing that we want to do is see the pairwise comparisons for each level. And so we can say, we'll do Tukey HSD for model 1, and that's still, this takes up a lot of space. Let's run that again. So this gives us the pairwise comparison for all 3 questions we ask. And so the first one it gives us is for that third party versus same party. And here it says third minus primary. So primary is the same party challenger. And it's negative 0.64. So the scale of this is a 1 to 7 scale, which means that on balance, third party challengers had about a half a point, more than a half a point, about 2/3 of a point less vote support on that 7-point scale. And then we have the p-value. Notice it says adjusted because we did Tukey multiple comparisons adjustment, and it's 1E-6. So again, that just says that there is a significant difference, and same party candidates in a primary were much more likely to get support than third party challengers in a general. And then we have moderate minus fringe, and it's a negative 1.0, so that's a full point on that 7-point voting scale. And since it's negative, that means that since it says moderate minus fringe, that means the moderate candidate was about a point less likely to, that the moderate challenger was about a point less likely to get support than the fringe challenger. And here the p-value, it just says it's 0. It's not exactly 0, but it says it's basically 0. So that gives us our two main effects. Now, this is the interaction effects. And again, these, it's not statistically significant. You might say, well, I still want to look at them because it's approaching statistical significance, and maybe I want to write something speculative in the discussion section. Or maybe you want to be disciplined and don't do that. But it's the same thing. We have the third-party fringe candidate against the primary fringe candidate. And again, the primary candidate was more likely to be supported than the third-party candidate, even when they were both from the fringe, and that's statistically significant, as indicated by the last p-value column. The primary moderate versus primary fringe is just a test of, okay, they're both the same political party, but one of them's moderate and one of them's fringe, and it suggests, yeah, the fringe candidate has an advantage here, and that's statistically significant. Now, third-party moderate versus primary fringe, okay, this should be a landslide for the primary fringe challenger because you're better off being in the same party and you're better off being a fringe challenger, and the difference is 1.66 on the vote scale, so that's again a big difference, no surprise there. The primary moderate versus the third-party fringe, maybe this is an interesting test for you because it's like, well, okay, if you're going to challenge from the center, is it best to do it in a primary where you stand a chance, or would you be better off being a third-party candidate in the general, but challenging from the fringe? And here it says the difference is 0.36, but it's not statistically significant. So really, you don't want to be moderate and you don't want to be a third-party challenger, and you can't really split the difference. You're not in an advantageous situation either way. For a third party, again, it just confirms you would rather be the fringe challenger than the moderate challenger, because third moderate compared to third fringe, you get about a 0.8 benefit for being the fringe compared to the moderate, and that is statistically significant. And then the third party moderate versus the primary moderate, it's like, well, okay, so if we're all going to be moderate or challenging from the center, does it matter if it's a third party challenger or if it's a same party challenger in a primary? And it looks like there's a little bit of a benefit to being a same party challenger in a primary, but the p-value is just 0.08, so it's not a statistically significant benefit. So this is, again, the long and short of it for our data set is that you're better off being in the same party than being a third party. You're better off being a fringe candidate than being a moderate candidate, and they don't really interact. So it's not like, well, you're better off being fringe if it's the third party challenge, but you're better off being moderate if it's same party challenge, or vice versa. That kind of interaction logic isn't supported by the data. We find two significant main effects and no interaction effect. Anyway, I hope you found walking through the process of doing a factorial analysis of variance pretty straightforward. It's not much more complicated than doing a traditional analysis of variance, but most experimental designs these days are a little bit more complicated than a one-way ANOVA would facilitate, so I thought this might be appreciated. Hope you liked it. Thanks for watching.